So now let's create a customer churn application that predicts whether customers churn or not. And if you want this data, it will be available in the description in case you want to follow along. This customer churn data set is for a tourism company that I got from Cargo. So now first let's import the necessary libraries. So let's import pandas as PD, import numpy. We want to not display the warnings. I want to ignore that. And I want to set a global random seed. So if you're following along, your data will be split the same as mine. So I'm going to import random. I'm going to say random.seed. I'm going to set it to 42. And also np random.seed to 42. So let's run that cell. Let me delete these cells. Next, what I want to do is load the data set. So I'm going to set the data frame to pd.read_csv. And what we want to load is, the name of our CSV file is customertravel.csv. Now let's take a look at our data frame. And we have these features and we want to predict whether a customer churned or not. So next we have to prepare the data for modeling. Let me add a couple more cells. And first I want to see if there's any null values in our data set. So df.isNull sum, and let's run that. Oh, this is a markdown. Let me change it into a code. And you see there's no null values in our data set. Let's look at the value counts for the churn and not churn column. df.target.value counts. Let's run that. And you see we have an imbalanced data set. We're going to set these two to be equal so we can get a better model because this is imbalanced. But first I want to look at the unique values for each of the columns. So I'm going to print our data frame. Then I'm on this column. I just want the unique values for the categorical columns because we need to change these two numbers, these yes and no's, and the middle, low, and high income. So then I'm going to call the unique function. Let me copy this, print it 4 more times. Then I'm on the annual class income column. The account syncs to social media column. Control C, Control V to paste it. And then I want the booked hotel or not. And let's run that. The reason why it's showing like this is because this bracket should be at the end. Let's run that cell. You see for the frequent flyer, the unique values is no, yes, no record. Annual income is middle income, low income, and high income. And for these two columns, it's yes and no. So next we have to change these into numbers. And the way I'm going to do that is with the map function. So I'm just going to speed through this because we did it in our previous lessons. And we changed our data set from having yes and no values to numbers. So now let's handle the imbalanced data. Let me delete these cells. Let me scroll up and get the value counts again. Control C, Control V to paste, and let's run that. So now let's do some undersampling. First, we need to separate the no churn and the churn. So I'm gonna say churn underscore 1, set that equals to our target column, and we want everything that's 1. Next, we want no churn 0, and set that to everything in our data frame where the target equals 0. And now let me print the shape of these two data frames. So print churn1 dot shape, and I also want to print no churn dot shape, and let's run that. Okay, we need to put 2 equal signs for here, and let's run that cell. The customers that churn, we have 224 rows for them, and the customers that didn't churn, we have 730, and we put each of these in these 2 variables. So now let's do some undersampling. So I'm gonna take 224 random samples from the churn. So no churn 0 sample. I'm gonna set that to no churn underscore 0 dot use the sample function, and then we're gonna set n to equals, let's say 230. I won't do it exactly as 224. Let's do 230. And then let me copy this and then get the shape. Control C to make sure it did what we want. Let's run that. So now let's concatenate this no churn sample with the churn sample. So let's set our data frame to equals pd.concat no underscore churn underscore 0 underscore sample, and we want to concatenate with this churn data frame. Then we're going to set the axis to equal 0. So now let's look at our target value counts now. And you see now we have a better balanced data set. So let's put our features in X and our target in Y. So I'm going to set X equals to df.drop, and we want all the columns in our data frame except the target column. And I'm going to set the axis to 1 because I'm dropping a column. Now let's set the Y to our target column, and let's run that cell. And next, let's split our data into training and test sets. So I need to first import train test split. So from sklearn.model underscore selection, we want to import train test split. And then we're going to say xtrain, xtest, ytrain, y test, and we set that equals to train test split. Then we're gonna put our X or our features and then our targets. Then we're gonna set the test size to equal 0.2. So 20% of our data will go into the test subset and the other 80 will go into the train. And let's set a random state to 42. And then let's set stratify equals Y. Next, let's write a code to view the different shapes of the training and test subsets. So let's xtrain.shape, xtest.shape, ytrain.shape, and the ytest.shape. And let's run that. Oh, I put a comma here instead of a period. And let's run that. And you see for the X train, we have 363 rows, 6 columns. The X test, 91 rows and 6 columns. The Y train, 363 rows, which is the target, and there's only 1 column. And the Y test is the other 20%, which is the 91 rows with 1 column. So next, let's prepare 3 machine learning models. So the first one I'm gonna do is a support vector machine. And from sklearn.linear model, we're gonna import logistic regression. And then from sklearn.ensemble, we're gonna import a random forest classifier. Let's run that cell. Let's create a couple more cells here. So now I'm going to create a dictionary with all the classification models we've imported. So later on, we can see the accuracy score for all 3. So let me set a variable called models and create the dictionary, SVC. And then we're going to initialize our support vector machine. And in brackets, I'm also going to set the random state to 42 for reproducibility. I know we set a global random seed, but I'm just going to put these in each of the models just in case. So I'm going to initialize the logistic regression. Also, give it a random state of 42. Then I'm going to do the random forest classifier. Also give this a random state of 42. Then I'm going to create an empty dictionary and set it in the variable results. And let's run that cell. So next I'm going to loop through the dictionary items that we just created, fitting the models on the training data and appending the model name and model score on the test data to the training results dictionary. So I'm going to set for model name, and right now I'm creating our for loop. Model and the models variable that we created above dot items. And I'm going to say model dot fit. I'm going to fit our X train and our Y train. So this is where the training is happening for all 3 of our models. Then I'm going to call the results model name, and then I want the score for all of these. So model.score, X test and Y test. And then let's call our results variable and let's run that. See what we get. And you see for our support vector machine, we got a score of 56%, the logistic regression 71, and the random forest classifier we got 86. So we're gonna go with our random forest classifier since it gave us the highest score. So next, let's check for overfitting or underfitting. So first I have to import, I want to import accuracy score. So sklearn.metrics, import accuracy score. So first, let me write some code to evaluate the training set. So train underscore predictions, set that equals to model.predict. And the reason why I could use model for our regressor is because Python code executes from top to bottom. So here it runs from top to bottom. So automatically the model will have the random forest classifier. If I wanted a different model like the logistic regression, I could have just write this code, I could set model to equals to the logistic regression. So you get the point. But since Python code executes from top to bottom, I could just, and the random forest regressor is the last one, I could just use model. Or I could set a variable called model and set that to random forest classifier with the random state 42. But I don't need to because, like I said, the Python code runs from top to bottom and the random forest classifier is our last model. And you will see when we get the results, we will get this same 8.868. So for the training predictions, I'm gonna put X train. In the next variable, I'm gonna call train accuracy. Then I'm gonna use the accuracy score that we imported from sklearn metrics. And then I'm gonna, the two arguments it takes is the Y train and the train preds variable that we just created. Next, I wanna evaluate the test sets. So I'm gonna set test predictions, set that equals to model.predict, and what we wanna predict is the test. And we set a variable called test accuracy. Accuracy score. And here we want the Y test. And then the test spreads. So now I want to print training accuracy. And I'm gonna copy this. Change this to test accuracy. Now let's run that cell. And you see for the training data, we got our random forest classifier gave us a score of 96, and the test accuracy score gave us 86. And like I said, the random forest classifier, that score is 86 here, and it will give us 86 here because this model, it took the random forest classifier since it was the last one. If we wanted the logistic regression or support vector machine, we would set model to and initialize the logistic regression. But we don't need to do that. This results indicates a potential overfitting issue, but it's not that extreme. It's a difference of 10. So here we could see the model performs very well on the training data, which means it captured patterns in the training set effectively, but there's a drop in performance on the unseen test data, which suggests that the model might be overfitting the training data. So just to explain overfitting and underfitting, the overfitting occurs when a model learns the training data too well and it doesn't generalize new data. So the difference of 10 between the training and test suggests a mild overfitting. And underfitting occurs when both training and test accuracy are low. So in this case, we don't have any underfitting, but there's a little overfitting. So to continue, we will see if we can make this better when we improve our model using random search CV. So now let's do some hyperparameter tuning. And first, let's set our grid. So we're gonna do a random search CV. So I'm gonna call this variable RF grid. And these parameters I just Googled. So I'm just gonna go through them, speed through them quickly. Let's run that. Let me add a couple more cells just in case we will need it. Let me set up a random seed just in case. Next, let's import a random search CV. So this is a markdown. Let me put it in code. So from sklearn.model selection, import randomized search CV. Let's run that. Next, let's set up an instance of the random search CV. So I'm going to call it rf_clf. Then I'm going to call out random search CV. And I'm going to set the estimator to our random forest classifier. And I'm going to set the parameter distribution to our RF grid that we set up 2 cells above or 3 cells above. Set the crossfold to 5. The iter to equals 50. I need a comma after here and also here. Then set the variables to equals true. If you don't know what any of these mean, I explained it in the previous lessons. So next, let's fit the instance of the randomized search CV. So rf_clf dot fit. Gonna fit the X train and the Y train, and then let's run that. It should be randomized, not random. Let's run that. The F in forest should be capitalized. Let's run that. It should be param distributions with an S. Let's run that. So now we have fit the instance of our random search or randomized search CV. So next, let's look at the best parameters. So I have to say rf_clf dot best_params, and it takes an underscore after that. Let's run that. And you see here it took the best parameters. So if we go up, we set all these n estimators, and it said that 50 is the best n estimator, the min sample split is 2, and so on. So it randomly went through all of these and shows the best parameters. So now let's check the underfitting and overfitting score for the instance of our random search CV. So let me print our random forest CL, which is the instance of our random search CV dot score. Let's put the X train and the Y train. Next, let's print the rf_clf dot score. Then we want the X test and the Y test. And you see let's scroll up to compare. So our the accuracy on the testing, it went down by 84, but we have less of an overfitting. Over here, the overfitting there was a difference of 10. And let's see down here, we reduced that to 7. So even though up here the baseline model, we got a higher test score, when we use randomized search to find the best parameters, we went down to 84, but there is less of an overfitting. So which one should I choose? I'll just go with this one to continue our model and to use it for our application. So next, I'm going to do some model evaluations. The first one I'm going to do is confusion matrix, but I'm going to import all the other matrix so that we could do a lot more model evaluations. So from sklearn.metrics, we want to import confusion matrix, a classification report, and also from sklearn.metrics, we want to import precision score. Well, I could have just added this on top here, but I'm already here. Recall score, F1 score. The classification report should have an underscore between. From sklearn.metrics, I'm gonna import the raw curve. So I'm gonna do a plethora of model evaluations, and I'm just doing it for your viewing, so you know all the ones we can use, but you don't necessarily have to use all of them. So let's make predictions on the test data and save them. Let me make sure I ran this cell. I spelled confusion wrong. Let's run that. And everything is okay. It creates a couple more cells. So let me make predictions on the test data and save them into our variable ypreds and set that equals to, what did we name our, yeah, we named it rf underscore clf dot predict. I want to predict the x test. So let's create a confusion matrix. So confusion underscore matrix. Then we're gonna put our y test and our y predictions. And let's run that. Oh, this cell is not a code. So let me put it in code and then let's run it. And here we have our confusion matrix. But I'm gonna display this a little better and then I'm gonna explain what's going on here. So from sklearn.metrics, we're gonna import confusion matrix display. Then I'm gonna say confusion matrix display dot from predictions, and we're gonna set y true to equals y test and the y pred to equals the y preds variable we created. And I'm gonna say plt.show. Let's run that. Okay, the reason why we're getting this error is because we have to import matplotlib. So I'm gonna import matplotlib.pyplot as plt. Let's run that. Hopefully our message is gone. And here we have our confusion matrix display. So what this shows that when our model predicts 0 and we go up, the true label is 1. So when we predict 0, there's 7 times that our model got it wrong because it predicted 0 and this is the true label. And then when our model predicts 0, it got it right 39 times because the 0 here, it predicted 0 and our true label is 0. So 39 times the model predicted that a customer did not churn. And 1, when our model predicts 1 or when it predicts that a customer did churn, the model got it right 38 times because our true label here is 1 and it predicted 1. When we predicted 1 and the true label is 0, so it got it wrong 7 times. So next, let's do a classification report. So I'm gonna print classification underscore report. Then I'm gonna set the y test to y predicts or y preds. And let's run that. And here's all the values to our classification report. To speed this up, I already explained what precision recall and F1 score meant in our previous lessons. So this was supposed to go under here, but we'll just skip through that. the area under receiver operating curve. To do that, I'm gonna from sklearn.metrics, I'm gonna import the rock curve display. Next, I want to get the predicted probabilities for the positive classes. So I'm gonna set a variable called y score, set that equals to our RF CLF dot predict, and I want to predict the X test, and I only want the positive classes. So now I want to create and plot the rock curve. So I'm going to set a variable called rock display, set that equals to rock curve display dot from predictions, and that takes our y test, the y score that we just created, which is the probabilities for the positive class. Then I'm going to set the name to equals ROC curve. Then I'm going to say PLT show, and let's run that. Oh, we're not supposed to, it's supposed to be predict proba, because the predict probabilities will give us probabilities of both the positive and negative class. So let's run that cell. And you see the area under the rock curve is 0.95, and the area under the curve can correctly tell the difference between someone who will churn and someone who won't churn 95% of the time. So now our final metrics is the cross-validation scores. Again, you don't have to do all these metrics, but I'm just doing it so that you would know how to do them. So let me import cross-validation score. So from sklearn.model underscore selection, we want to import cross-val score. So first I want the cross-validated accuracy. So I'm going to set a variable called cross-val accuracy. Then we call our cross-validated score. Then we call our randomized search model, which is RF underscore CLF. We want the X, we want the Y. And with cross-validation, we don't need train test split, because we're splitting our data into 5 sections or 5 groups or subsets, and then we average out those scores. So I'm gonna set the scoring to equals the accuracy, and we set CV to 5 because we want 5 subsets. So now I'm gonna print the cross-val accuracy, and then I'm gonna take the average of each of the 5 scores that we get. So then I'm gonna print np.mean, and we want the mean of the cross-val accuracy. So let's run that, and it might take a little while, so I'm gonna pause the recording and come back to you once it's done. So now it's done, and here is each of our 5 subsets, and when we average it out, we got a cross-validated accuracy of 0.883. So with the train test split, I think, or when we improved our baseline model with the randomized search CV, the accuracy was 0.84, and with our cross-validation, it's 0.88. We can also find the cross-validated precision, recall, and F1. So let me just copy this, Control-C, Control-V to paste. And the only thing we need to do is change from accuracy, and if we wanted the precision, we just type precision here. And let's also change these variables, and let's call it PRE for precision. And then I could run that, and that's also gonna take a while. And while that's loading, I'm also gonna do the recall and F1. So I'm gonna paste this here and paste this here, and instead of accuracy, I'm gonna put recall. Instead of scoring, I'm gonna put F1. And I'm also gonna change these variables and put cross-validated REC for recall. Then I'm gonna change these ACC for accuracy and do F1 for F1 score. So once this is done, I'm gonna run this cell and this cell to get the cross-validated score for the recall and the F1. So it's done calculating the cross-validated precision score. Let me run this cell while I explain. We divided our data into 5 subsets, and in this one we're trying to find the precision score. So when we divided our data into 5 sets, we found the precision score for each of the 5 sets, and then we find the average, which is 87. And then we're gonna do the same for the recall and the F1. So for the recall, the cross-validated recall score, we got a score of 91, and the cross-validated F1 score, we got a score of 88. So now let's make a predictive system. But first, let's save our encoded data frame so we can take features to make predictions. So df2.to CSV, and I want to save the encoded CSV. So I'm gonna call it coded customer travel .csv, and then I'm gonna set the index to false because I don't want an index. So let's run that. And if you look into the folder where you're working on this Jupyter notebook file, you should get the coded customer travel. So I'm gonna open this, and I want to open it with Notepad. So here is our features, and the targets is here. So we're gonna use this to make predictions. So in the predictive system, first we need the input data, and I'm gonna put data in shortly after I write the rest of the code. And then I need to change the input data as an MP array. So input data as array. I'm gonna set that equals to np array. Put the input data. Then I want to reshape 1, -1. And we need to reshape the array because we are predicting for one instance. So next I'm gonna create a variable called prediction. And then we're gonna call our model rsclf.predict. I'm gonna predict input data as an array, and then I'm gonna print the prediction. And also I want to say if the prediction is equals to 0, I should surround this with brackets. So if prediction is equal to 0, I want to print this person did not churn. Or I could also put / they are still using our services. Then I want to set an else, and then I'm going to print this person churned / they are no longer using our services. So let me find some data to input. So I'm gonna do this first one. So 31 01301 01301. Let me make sure I'm putting the correct values. 31 01301. and it should tell me that this person did not churn. It should bring back a 0. So let's run that. Okay, this should be predict, not prediction. Let's run that. And you see here it told me that this person did not churn / they are still using our services. Let me do one where they churned. Let me do this first one. So 34, I believe this one was 1. Let me double check. 34 1 0 5 1 0. 0 5 1 0. Let me double check it. 34 1 0 5 1 0. And it should tell me that this person churned, and it should be a 1 here. But remember, our model is not 100%. So if we put all of this, it won't get all of it right. So let's run that. And you see we got a 1 telling us that this person churned. So now let's save the model. So I'm gonna do this using Pickle. So I'm gonna import Pickle. So now let's save the model to our same folder that this Jupyter notebook file is. So pickle.dump. And let me see, what was the name of our model? rf_clf. Next we have to say open, and in quotes we put what we want to name our saved model as. So I'm gonna call it rf_clf_churn, and we have to give it the pkl extension. And next we have to put w in quotes, which means write binary. And let's save this cell, and let's look at the folder. And you see here it saved our model into the same folder that has our Jupyter notebook file.